Imagine this. You're sitting in your living room, holding a cup of coffee. You let it slip from your hand, and it falls to the floor. You don't have to think about why it happens. It just does. Gravity, right? The invisible force pulling things down. Newton told us that. Or did he? For centuries, we've believed in this simple, almost comforting story. Objects attract each other with a force proportional to their masses. Apples fall, planets orbit, tides rise, all explained by this universal tug-of-war. But if we look closer, if we think carefully about the universe, something curious emerges. Gravity, perhaps, is not a force at all. Before your mind protests, let's take a small journey. Picture a trampoline, stretched tight. You place a bowling ball in the center. What happens? The fabric bends, curving under the ball's weight. Now roll a smaller ball across the surface. It doesn't just slide in a straight line, it curves toward the heavy ball. It seems as though an invisible hand is pulling it, doesn't it? But there is no hand. There is only the curvature of the trampoline. This is a shadow, a hint of the deeper truth about gravity. Newton's genius was undeniable. He gave us the language to predict the planets, to launch rockets, to land on the moon. Yet he imagined gravity as a mysterious force acting at a distance. How could the sun tug on Earth across millions of kilometers? That question nagged at scientists for centuries. Even Newton admitted he didn't know how it worked. He called it an action at a distance, a phrase almost like a confession. Then came Einstein, and with him a startling revelation. Gravity is not a force, not in the way we think of a push or a pull. Instead, gravity is geometry. Space itself is curved, and matter, like planets, stars, and you holding that coffee cup, moves along the curves. The coffee doesn't fall because it's being pulled. It falls because it's following the natural path carved out in the fabric of spacetime. In a sense, it's moving straight, only straight, in a curved universe. Let's pause and imagine this. Close your eyes, and picture the universe as a vast invisible trampoline, stretching in all directions. The sun sits in the middle, a massive weight bending the fabric. Earth orbits in a graceful ellipse, tracing the curves around the sun, not because it's being pulled, but because the path itself is shaped that way. This view turns Newton's world upside down, not in opposition, but as a deeper layer. Newton's laws still work wonderfully well, but they are approximations, shadows of the underlying geometry, and yet the story doesn't stop there. If gravity is geometry, then the universe is not just a stage where events unfold. It is a living stage, shaped by the very things that move upon it. Mass tells space how to curve, and space tells mass how to move. It's a dialogue between matter and the arena it inhabits. Every planet, every star, every particle participates in a cosmic dance choreographed by curvature itself. But why does this matter to us in our everyday lives? Consider the GPS in your phone. Satellites orbiting Earth aren't just floating in emptiness. They move along curved spacetime. If engineers ignored the effects of Einstein's curvature, the GPS would be off by kilometers every day. What seems like abstract theory becomes practical reality. The curvature of spacetime guides our technology, our journeys, our understanding of the world. Now, let's stretch our imagination even further. Black holes, regions of spacetime so curved that not even light can escape. Once again, no mysterious force dragging things inward. The paths themselves plunge into a bottomless pit of geometry. Time and space themselves become tangled. And if you think that's strange, consider gravitational waves, ripples traveling through the fabric of spacetime itself, stretching and squeezing the universe like a cosmic symphony. Scientists have now measured them, confirming that spacetime is real, tangible, and dynamic. Gravity, in its deepest sense, is motion along the curves of this invisible stage. But here's where it becomes even more profound. If gravity is geometry, then space and time are not merely backdrops. They are active participants, living entities in a sense, shaped by mass and energy. The universe is not just matter moving through emptiness. Emptiness itself bends, stretches, and dances. Our everyday intuition, the idea that space is a passive arena, is overturned. The cosmos is alive in the most subtle, elegant way, and yet questions remain. At the smallest scales in the quantum world of electrons, quarks, and photons, gravity refuses to behave like the smooth curves Einstein described. Space may not be continuous, it may be grainy, foamy, unpredictable. Here, in this frontier, the geometry of spacetime may be just an emergent illusion, hiding a deeper, almost unimaginable reality. Scientists like Roger Penrose have speculated about the fundamental nature of these structures, suggesting that perhaps we are glimpsing only shadows of the true rules of the cosmos. Let's bring it back to the coffee cup. You dropped it. It fell. You cleaned it up. But every falling object, every orbiting planet, every photon bending near a star, is revealing a story about the universe. Newton described the pattern, Einstein revealed the stage, and now as we explore deeper, we begin to glimpse the underlying symphony. Gravity is geometry. Gravity is the curvature of space. Gravity is the universe speaking to us in the language of motion. And here is the mind-expanding thought. What if our intuition is always one step behind reality? We think of forces as pulls and pushes, because that is what we see, what we feel. But the universe whispers a different story, one of elegance, subtlety, and unexpected beauty. Gravity is not a force. It's a hint that the universe is far richer, stranger, and more wondrous than even Newton or Einstein imagined. So the next time you let a cup fall or watch the moon trace its path across the sky, remember, you are witnessing geometry in motion. You are seeing the curves of space-time bending around massive objects. You are glimpsing the deep order beneath the apparent chaos of motion. Every moment, the universe is revealing its hidden architecture. And finally, let me leave you with a question. Not a problem to solve, but a reflection to ponder. If gravity is geometry, what else are we misunderstanding about the very fabric of reality? What other truths lie hidden behind the things we take for granted? The universe is vast, elegant, and mysterious, and perhaps like gravity, its deepest secrets are not what we thought they were. So keep asking, keep imagining, and never stop marveling. For in these questions, in these small acts of wonder, we touch the face of reality itself. And yet, even as we embrace this vision of gravity as geometry, our minds can't help but wonder, how does this invisible curvature of space-time know where to bend? What decides how the Earth curves space around it? Or how the sun carves its paths into the cosmos? It's almost as if the universe itself is aware, not conscious perhaps, but organized with a logic so profound that it operates silently beneath our senses. Think about the moon orbiting Earth. Newton would say it is pulled by a force toward the planet. Einstein says it is following a straight path along a curved fabric. But neither of these explanations fully captures the poetic subtlety of the scene. Imagine a cosmic river flowing through space. The moon is a leaf on that river, moving naturally along the currents carved by mass and energy. The currents themselves are invisible, yet they shape every motion. The moon's trajectory, the tides it induces, the quiet night sky, all are consequences of a hidden geometry, an unseen choreography. And here's a marvel. This curvature is not static. When massive stars explode as supernovae, the fabric of spacetime itself ripples, sending gravitational waves across the universe at the speed of light. These waves stretch and squeeze everything they pass through, even if just by an almost imperceptible amount. Imagine a pond, smooth and still. You toss a stone, and ripples radiate outward. Only in this case, the pond is the entire universe, and the stones are exploding stars, colliding black holes, and massive cosmic events. Scientists have detected these waves, not with our eyes, but with instruments so sensitive they can measure shifts smaller than a proton. Now consider a human perspective. We walk through the world thinking it is flat, solid, predictable. Yet beneath our feet, and around every corner of the cosmos, the universe bends, stretches and flows in ways our intuition cannot grasp. Gravity, as geometry, is the first hint that reality is stranger than we dare imagine. Even a simple act, jumping into the air, is a dialogue with space-time itself. When your feet leave the ground, they follow paths carved by the mass of the Earth. You arc upward and then return, entirely unaware that you are tracing the contours of a curved four-dimensional stage. Let's zoom in further. Imagine a photon, a single particle of light, traveling across the universe. It passes near a massive galaxy. Its path bends. No force pushes it, no hand pulls it. The light simply follows the curves of space-time, and in doing so it reveals another secret. Geometry dictates behavior, even for the most ethereal entities. Gravity, it seems, is democratic. It acts on everything, from massive planets to massless light, shaping motion with elegant impartiality. And what about black holes? These regions of space-time curve so sharply that paths vanish, spiraling inward toward an unseen singularity. Here, time itself slows, bending to the will of gravity. For an observer falling in, seconds stretch to infinity. For someone watching from afar, the fall appears frozen. The very fabric of reality is stretched, folded, and contorted. Gravity as a force cannot explain this. Only geometry, deep and intricate, offers a lens to glimpse these extremes. Now let's ask another question, one that bridges science and philosophy. If space-time can curve, ripple, and warp, what is its origin? We often speak of empty space as if it is nothing, a void, but empty space is not nothing. It is a dynamic entity, capable of bending, storing energy, and propagating waves. It is the canvas on which all existence paints itself, and just like a canvas, its texture influences the forms that emerge. This raises the most profound question. Is space-time fundamental, or is it itself emergent, a macroscopic manifestation of an even deeper reality we have yet to imagine? Roger Penrose has suggested that at the quantum level, the smooth geometry of space-time might dissolve into something far more mysterious, a foam-like structure, unpredictable, discontinuous, and perhaps even fundamentally non-deterministic. The elegant curves we see around stars and planets may be the large-scale averaging of a frothing, discrete reality underneath. If true, this hints that our universe is even more wondrous than general relativity allows. Gravity is a clue, a bridge between the familiar and the profoundly unknown. And yet, despite all this abstraction, gravity remains intimate. Every time you drop a coin, jump from a step, or gaze at the moon, you are participating in these universal patterns. You are moving along the curves carved by mass, energy, and the unseen structure of space-time. You are, in a very real sense, dancing with the cosmos. The mundane and the cosmic are inseparable. There is poetry in this fact. The same laws that bend light around distant galaxies govern the simple act of your feet returning to the floor. Here is a paradox worth pondering. We have used Newton's laws to send humans to the moon, yet the deeper truth of gravity was only revealed later. This teaches us humility. Our intuitions, our common sense can mislead us about the universe. Reality is subtle. Reality is profound. Reality is often stranger than our imaginations, and this invites wonder. Imagine now standing on a quiet hill at night. The stars shimmer, the planets trace their paths, the moon hangs like a lantern. Every point of light you see is part of the vast curvature, following paths shaped by invisible geometry. The universe is alive with motion, yet silent. It bends, it ripples, it flows, all without the slightest hint of force in the Newtonian sense. Gravity is geometry. Gravity is subtlety. Gravity is a window into the extraordinary order, hidden behind everyday appearances. And what does this mean for us? Perhaps it reminds us that understanding is a journey. Each discovery peels back a layer, revealing new questions, new mysteries, new beauty. Perhaps it tells us that to truly know the universe, we must be patient, humble, and imaginative. Gravity, in its deepest essence, is both simple and profoundly mysterious. It is the quiet storyteller of the cosmos, whispering truths that we are only beginning to hear. So the next time you pour a cup of coffee, watch an apple fall, or glimpse the moon in the night sky, remember you are witnessing geometry in motion. You are part of a story written across space-time. You are a participant in the grand choreography of the universe. Gravity is not a force. It is a lens into the invisible architecture of reality. It is a reminder that the universe is far more elegant, subtle, and wondrous than even our most brilliant minds can fully grasp. And finally, let me leave you with a thought that lingers long after the video ends. If gravity is geometry, shaping the paths of everything, then perhaps every act, every motion, every interaction we witness is a clue to the deeper structure of reality. What else in the universe, in our lives, in our perceptions, is not what it seems? What hidden truths are waiting for us to notice, to understand, to marvel at? The cosmos invites us to keep asking, keep imagining, and keep exploring, because the universe, in all its subtle curvature and hidden elegance, is far from done revealing itself.